Sige.
The next topic is the gas turbine power plant. So what is gas turbine? Gas turbine is a machine delivering mechanical power or thrust. It does using a gaseous working fluid. The mechanical power generated can be used by, for example, an industrial device. The outgoing gaseous fluid can be used to generate the thrust in the gas turbine. There is a continuous flow of the working fluid. Its efficiency is up to 20 to 30%, whereas that of steam power plant is 38 to 48% major. So we know the definition of gas turbine. We need to know next is the application of gas turbine. So what is the application of gas turbine? Gas turbine is aviation which is self-contained, lightweight, and don't require cooling like other power plants. Next, it can use as power generation, And number 3 is oil and gas industry is cheaper supply of fuel and low installation costs. Gas turbine power plant is one of the most cheapest power plant among the power plants. Next is marine propulsion. So we know the application. We must need to know what is the principle of gas turbine. So first is it squeezes the air to high pressure by a compressor. Next is the fuel and compare air are mixed in a combustion chamber and ignited. The third is hot gases are given up which spin the turbine wheels. Next is the gas turbine burns fuel such as oil, natural gas, and pulverized powdered coal. And lastly, gas turbines have 3 main parts: the air compressor, combustion chamber, and turbine. So what are the advantages and disadvantages of gas turbine? So first is advantages. It is store of fuel require less area and handling is easy. Second is, like I said, the cost of gas turbine power plant is low. Third is, it is simple in construction. There is no need for boiler, condenser, and other accessories as in the case of steam power plants. Next is, it is cheaper fuel such as kerosene, paraffin, benzene, and powdered coal can be used, which are cheaper than petrol and diesel. Next is gas turbine plants can be used in a water scarcity areas. And lastly, less pollution and less water is required. But here are some advantages of gas turbine. There are 66% of the power developed is used to drive the compressor. Therefore, the gas turbine unit has a low thermal efficiency. The running speed of gas turbine is in the range of 40,000 to 100,000 revolution per minute, and the operating temperature is high as 1,100 to 12,600 degrees Celsius. For this year, special metal and alloys have to be used for the various parts of turbine. So which is medyo costly siya. Dun lang mamahal. And next is a high frequency noise from the compressor is objectionable. Next. So here are the types of gas turbines. First is the open cycle turbine power plant. In this power plant, in this type of plant, the atmospheric air is in charge into combustor through a compressor, and exhaust of the turbine also discharged to the atmosphere. As you can see in the schematic diagram, first is fresh air inlet going to compressor, Then the fuel goes to combustion chamber, and after ignited, it will go to gas turbine, and the turbine will rotate. Then it produces power, yun last, shaft power. Okay, next. Gas turbine usually operate on an open cycle. Air at ambient condition is drawn into the compressor, where its temperature and pressure are raised. The high pressure air proceeds into the combustion chamber, where the fuel is burned at constant pressure. The high temperature gas then enter the turbine, where they expand to atmospheric pressure while producing power output. Some of the output power is used to drive the compressor. The exhaust gases leaving the turbine are thrown out, not recirculated, causing the cycle to be classified as an open cycle. Just like I said, yung open cycle ay hindi naulit ng process. Hindi kagaya na yung closed cycle power plant. Next. Next is the ideal cycle that working fluid undergoes in the closed loop is the Brayton cycle. So what is Brayton cycle? Brayton cycle is a thermodynamic cycle that describes how gas turbine operate. The idea behind the Brayton cycle is to extract energy from flowing air and fuel to generate usable work, which can be used to power many vehicles by giving them thrust. The most basic step in extracting energy is compression of flowing air, combustion, then expansion of that air to create work and also power the compression at the same time. So point 1 to 2 is isentropic compression, where no change in entropy. Point 2 to 3, which is constant pressure with heat addition. While in point 3 and 4, it is isentropic expansion, then point 4 and 1, constant pressure, and it reject heat. That's all. Thank you.